So next topic or last topic of this chapter, change of variable, that is substitution in double integral and in triple integral. First is double integral. So in order to change the variable, we first see the definition of Jacobian. So x is the function of u and v and y is also function of u and v. Then the Jacobian JUV. The notation for JUV is what? J dava x dava xy dava uv. So this is the notation for Jacobian. Either write capital J in bracket u comma v or J dava x comma y dava u comma v. So that is notation for Jacobian. So x and y both are the function of u and v. So is what? Dava x by dava u dava x by dava v, and is the determinant dava x by dava u dava x by dava v dava y by dava u dava y by dava v. This is the definition of the Jacobian. Dava xy dava divided by dava uv is what? Dava x by dava u dava x by dava v dava y by dava u dava y by dava v. And that is the determinant is, we know that this into this minus this into this. Okay. So if the notations are theta, r, x is the function of r and theta, then dava x y by dava r theta, because x and y are the functions of r and theta, dava r theta, or j dava r theta, or dava xy dava r theta. Those is notation. And is what? Dava x by dava r dava x by dava theta by using this definition, and dava y by dava r dava y by dava theta. And dava x by the x is r cos theta, so its derivative with respect to r is cos theta. Dava x by dava theta, dava x by dava theta is r is now constant, derivative of cos theta is minus sin theta, so minus r sin theta. Dava y by dava r is r cos theta, r with respect to r sin theta is the derivative of r is 1. Dava y by dava theta is r cos theta, and then its determinant is this into this, that is r cos square theta minus plus r sin square theta. Take r as common, then cos square theta plus sin square theta is 1. So r. So if x is r cos theta and y is these are the polar coordinates, then Jacobian is r. And the Jacobian of the three variable function x is and y both are function of u v w, then dava x y z dava u v w, there is Jacobian is what? Dava x by dava u dava x by dava v dava x by dava w. Same definition, but determinant of order 3 by 3 matrix. Dava x by dava u dava x by dava v dava x by dava w, then dava y by dava u dava y by dava v dava y by w, dava z by dava u dava z by dava v dava z by w. Okay, so if x is r cos theta, y is not x is rho cos theta, y is rho sin theta, and z is equal to z. That is then Jacobian is what? Jacobian dava x y z divided by dava rho theta and z is what? Dava x by dava rho dava x by dava theta dava x by dava z, then dava y by dava rho dava y by dava theta dava y by dava z, and dava z by dava rho dava z by dava theta dava z by dava z. Okay, and then dava x by dava rho is cos theta, then dava x by dava theta is rho is now constant, and derivative of cos theta is minus sin theta. So write rho or r. Here is the notation r. So write here rho notation, and then dava x by dava z is 0, then dava y by dava rho is sin theta, dava rho by dava y by dava theta is rho is now constant, sin theta derivative is cos theta, so I write rho cos theta, and dava y by dava z is 0, then dava z by dava rho is 0, dava z by dava theta is 0, and dava z by dava z is 1. And so its determinant is this. Determinant is what? Rho cos square theta plus rho sin square theta. That is cos theta, this into this minus this into this, then minus plus r sin theta, this into this minus this into this, and lastly 0, this into this minus this into this. We have this answer. Determinant, find determinant, we have the rho answer. Then change of variable in double integration. So this is the theorem that if I have to change the variable, double integration of r fx dx dy. So if you have to change the variable, suppose x is uv, function of uv, guv, and y is h of uv. Then replace x and y in terms of u and v, in that function, and this dx dy is replaced by mod juv. What is mod juv? That is j, that is dava xy dava uv, and into du dv. So what is dx dy? Dx dy is replaced by mod j du dv, and x and y are replaced by the new variable u and v, the functions of u and v. So this is the theorem to interchange the to change the variable in double integration. That is write the double integration over g. Suppose this r match to the region g, then find double integration over g, replace x and y by new variables in the function, and this dx dy replaced by mod j du dv. So remember this theorem in order to change the variable. So this is the first problem, 0 to 4, x runs from y by 2 to this dx. By applying the transformation, u is equal to 2x minus y by 2 and v is equal to y by 2. That is why to change the variable x and y to u and v. So first diagram are essential. So x is from these two, what we have, x is y by 2. So x is y by 2. Draw the diagram of this integration. This is the diagram. X is equal to y by 2, means y is 2x. This is y is equal to 2x line passing through origin and and y is equal to 2x is the line. Y is equal to x is the line which divides this plane in two equal parts. So y is equal to 2x is larger than, its slope is larger than y is equal to x. So it is above the y is equal to x line. And this is the, then y is equal to, x is equal to y plus 2, y by 2 plus 1. X is equal to y by 2 plus 1. So this line means substitute then my x minus 1 divided by into 2, 2x, y is equal to 2x minus 2. So this is the line y is equal to 2x minus 2. This line is parallel to y is equal to 2x line, because slope is 2, here slope is 2, and it passes through the point minus 2, 0. If we substitute x is 0, then y is minus 2. If we substitute x is 0, then y is minus 2. So the point is what? The here is 0 minus 2 point, x-axis, y-axis on y-axis. And if we substitute y 0, then x is 1. So this point is what? 1, 0 point, 1, 0, passing through point 1, 0. Because if y 0, then x is 1, 1, 0 point. So this is the line, y is equal to 2x minus 2. So the figures are important in order to change the variable. In order to change the order, and as well as in order to change the variable, figures are figure is important. So how we can draw the figure? We can draw the figure of by using limit in order to change the order of the integration as well as change the variable. So in order to change the variable and in order to change the order of the integration, the figure is important. The figure, how we can draw the figure? We can draw the figure from limit of that function, that integration. So now x is equal to, this is the limit on y. Y is equal to 0 means x-axis, and y is equal to 4 is this line, y is equal to 4. So this is the region bounded by these curves or straight lines, and region is called a region of integration. So, and we have to change this variables x and y to u and v. So this is the given. U is 2x minus y divided by 2, and v is y by 2. And therefore x is u plus v and y is 2uv, 2v. So solving this for u and v, for x and y, we get x is u plus v and y is 2v. So solving these two, we have the x and v. So x is u plus v, y is 2uv, 2v. So we have to convert this x and y to this. So in this integrand, that is this function, just replace x by u plus v and y by 2 y by 2v in this function. Okay, and dx dy is replaced by mod j. So what is mod j? J is first, right? J u v is what? J is mod daba x by daba u, daba x by daba v, daba y by daba u, daba y by daba v. So J is equal to daba xy daba uv, daba xy daba uv. So we had to convert the x and y in terms of u and v. So daba, right, juv, or right, is equal to daba xy daba uv is this, and then its derivative daba x by daba u is 1, daba x by daba v is 1, daba y by daba u is 1, daba y by daba u is 0, and daba y by daba v is 2, and therefore we have Jacobian is 2. And so double integration over r, this integration 2x minus y by 2 dx dy is equal to double integration over g, new region, this is g region suppose, and 2x, x is replaced by u plus v, minus y is right, 2v divided by 2, we have the answer u mod j du dv by using this formula, mod j du dv, that is just replace x and y by u and v, mod j du dv, and mod j is 2, so write that value is 2. And now the limit, this is the given integration, and that is equal to double integration over, so u runs from and v runs from, so u runs from, here is 0 to 1, how you can draw this? So this figure converted to this figure, so use this figure to left side and then right side, then arrow, this x is u plus v. So if you replace x and y by u plus v and 2u in this equation, then we have u is equal to 0, answer u is equal to 0. Right? If you write u, y as u, 2v, and x as u plus v, then we have the answer u is equal to 0. So this line y is equal to 2x in new variable replaced by this u is equal to 0. Then if you substitute y is equal to 4 in this, if you solve this y is equal to 4, that is y 2v is equal to 4, means v is equal to 2. So this line replaced by this line, v is equal to 2. Then y, substitute y as 2v and x as u plus v, we get answer u is equal to 1. So this is u is equal to 1 line. And v, this is y is equal to 0. So if you substitute y is equal to 0, then v is 0. So this region converted to this region. So from this figure, draw this figure. And then we had to integrate, suppose with respect to u first, then take strip parallel to u axis, this, like this strip parallel to u axis. And so u runs from, its one end touches to u is equal to 0, is one another end touches to u is equal to 1. So u runs from 0 to 1, And in order to cover this region, we have to move this strip from this point to this point, that is v runs from 0 to 2. V runs from 0 to 2. So we have this. This is called a change of variable. We converted this variable x and y in terms of u and v, and then write to mod j as 2 u du dv. Then integration with respect to u is u square by 2 to get cancel, lower limit upper limit value, and then dv integration is v from 2 to 0 to 2. So 2 is the answer. So this is the change of variable. The another problem is evaluate integration. So 0 to 1, 0 to 1 minus x root x plus y minus 2x bracket square dy dx by changing the variable. So these are the problems of change of variable. Sometimes the variables, change of variables are given, substitution is given, but if the substitution is not given, then we have to find its substitution. Here the substitution is given. If the substitution is given, then, so this problem, suppose change the variable x, y, z to r, theta and z in following integration, triple integration. over x square y dx dy dz. So R is the region. X square plus y square is less than 1. 0 to z runs from 0 to 1. Substitution x is equal to r cos theta, y is equal to r sin theta, and z is equal to 2. Do not evaluate the integral, just change the variable. So dx dy dz replaced by mod j dr d theta dz. Okay, so dr d theta dz. Z is equal to z, not to z is equal to z. It is right, z is equal to z. So dx dy dz replaced by mod j. So first find mod j, first find j. J is what? Deva x, deva y, deva x, y, z, because x, y, z, we have to convert x, y, z in terms of r, theta, and z. And so it is deva x by deva r, deva x by deva theta, deva x by deva z, deva y by deva r, deva y by deva theta, deva y by deva z, and then deva z by deva r, deva z by deva theta, deva z by deva z. And then the values of deva x by deva r. From this, we have this cos theta minus r sin theta 0, and solve this determinant. We have the answer r. Okay, and now this triple integration over r x square y dx dy dz. So x square means x square means r square cos square theta into y is r sin theta, and this dx dy dz replaced by mod z, that is r dr d theta dz. Okay, and we have to write the now limit. So limit are what? Limit are r runs from so from this x square plus y square is less than or equal to 1. If you substitute x as r cos theta, y as r sin theta, then r square cos square theta plus r square sin square theta is 1, and therefore r square in bracket cos square theta plus sin square theta is 1. R square is less than or equal to 1 means r is plus minus 1. So r runs from 0 to 1 because it is in first quarter. In first quarter, z is equal to z. Okay, z axis. So r runs from 0 to 1. Then theta runs from 0 to 2 pi. Theta runs from 0 to 2 pi. And z runs from 0 to 1. Z runs from 0 to 1. So r runs from 0 to 1. If we substitute these coordinates, then theta, we have to cover the all region, that is 2 pi means 360 region. So r runs from 0 to 1. So remember these limits. So this is the change of variable. So double integration in polar coordinate. So x is equal to r cos theta and y is equal to r sin theta is called polar coordinate. And then deva x, y, deva r theta is what? Is r. We know that if x is r cos theta and y is r sin theta, then deva x, y, deva r theta is what? Mod deva x, deva r, deva y, deva r, deva theta, deva x, deva r, deva x, deva theta determinant. And we know that x is r cos theta and y is r sin theta. Then Jacobian is what? So x is r cos theta and y is r sin theta. This is the answer. Deva x Jacobian is what? Deva x, deva y, deva x, y, deva r theta is deva x by deva r, deva x by deva theta, deva y by deva r, deva y by theta. Then this is the answer. R is the answer. Okay, this is the question for 2 marks. That is find Jacobian. Then if you have to change in polar coordinates, so x is r cos theta, y is r sin theta. So double integration over r fx y dx dy. So r is replaced by r dash, new region, and f of x is replaced by r cos theta, y is replaced by r sin theta, and dx dy replaced by mod j. Mod j is r. So r dr d theta. So example on this polar coordinate. Suppose this is the evaluate by changing the variable. So x square plus y square. If there is a factor of this type x square plus y square, then replace x and y by polar coordinate r cos theta and r sin theta, and therefore r x square plus y square is r square, and Jacobian is r. Okay, x square plus y square is less than or equal to r. So r varies from 0 to 1 because x square plus y square is less than or equal to 1. R varies from 0 to 1 and theta varies from 0 to 2 pi. In order to cover the circle, total circle, we have to move the theta from 0 to 2 pi, whole circle cover. If there is a first quadrant, if there is wording in the question that in the first quadrant, then theta runs from 0 to pi by 2. So in to cover the whole circle, x square plus y square is equal to 1 is the circle of radius 1. So double integration over a x square plus y square raised to 7 by 2 dx dy. So first replace x square and y square by r cos theta and r sin theta. Therefore, x square plus y square is r square raised to 7 by 2. Dx dy is replaced by mod j dr d theta. J mod j is r. So write r dr d theta is next step. So r square by 7 by 2 means r is 14 by 2. That is r is 7 into r into mod j is r. So r raised to 8 dr d theta. And what are the limit? Limit r runs from 0 to 1 and theta runs from 0 to 2 pi in order to cover the circle. So we solve this. We have the integration with respect to r is r raised to 9 by 9. Then value at upper limit. So 1 by 9 and 1 by 9 limit is integration is theta 1 by 9 theta and 2 pi minus 0, that is 2 pi by 9 is the answer. So if there is x square plus y square type factor, then use the polar coordinate. So these are the problems of that type. X square plus y square is the factor, then use polar coordinate. X square plus y square is a square. Okay, so here if we solve this equation, then we have x square plus y square is equal to a square circle. So if there is a such a type of factor, then use the polar coordinate to, that is, use x is r cos theta and y is r sin theta. So we will see the example of change of variable in the next lecture, remaining examples.